Okay. So in the last class on Tuesday, means on Saturday we did the series part, which was not for exclusively for the board for the J, not for the boards. But on Monday and Tuesday, the part that we have seen up till addition of the nth term of the arithmetic progression and the sum of n terms of the sequence. So sum of n terms of formula that we had.
Their voice is breaking,
was n
sir.
upon. Voice is breaking. For Afrin, for you also is the voice breaking?
Sir, in between is breaking, sir.
They are connected with the proper network. Means the better network that had with that I connected. Okay.
Sir, now it is proper, sir. You continue.
Okay. So Sn is equals to the formula that we saw was times.
Sir, full it is breaking, sir. Voice.
Okay, Pujita, for 5 minutes. Let's see if the voice still breaks. Then we will see some
Sir, it is
solution.
okay, sir. It is not breaking.
If it is not breaking for Afrin, means Pujita, the network issue is on your side. Means, otherwise, it should break for both of you. Means from my side, if the network problem is there. The insertion of n terms we have seen, the two fixed numbers a and b, two fixed numbers, and insertion of n terms in between them. So total we have to divide that interval between a and b into n plus 1 parts, n plus 1 equal distances. How to insert n terms in between such that all of them are in AP, that part we saw. After that, sum of n terms of an arithmetic progression, and the formula that we got was n number of terms upon 2, first term plus last term, or in the other words, number of terms upon 2 times a, that is first term plus n minus 1d. And we saw some problem over these questions. Let's solve. Basically, these two are the only formulas in an arithmetic progression. Let's solve some more questions about this. Question number 1. The sum of n terms of two arithmetic progressions are in the ratio 3n plus 8 upon 7n plus 8, or 3n plus 8 is to 7n plus 8. Find the ratio of the 12th terms. Okay, Afrin wants me to explain. Pooja, shall I explain? Okay, see. Okay, Afrin, you can just type EXP also in the chat box. No need to write such a thing. Okay, see.
Okay, sir.
The sum of n terms of two arithmetic progressions. Okay, so you can see that's AP1, the first AP. I don't know, AP1 and AP2, they will be completely different. This will be something like A1, and the term successive terms will be A1 plus D1, A1 plus 2 times D1, and so on. And the second AP will be completely independent, no relation with the first one at all. A2, A2 plus D2, A2 plus D2, no relation. However, the sum of n terms, whatever that formula is, n upon number of terms upon 2, twice of this A1 plus n minus 1 times D1. Here, n upon 2 times twice of A2 plus n minus 1 times D2. This ratio is given. Sum of n terms of first AP, AP1, upon sum of the same first n terms in AP2 is given by 3n plus 8 upon 7n plus 8. Okay, and what is asked is find the ratio of the 12th terms. The ratio of the 12th term is something like, and what means, what is asking, A1 plus 12th term is 11 times D1, yes or no? And for the second AP, the 12th term is A2 plus 11 times D2. This ratio is asking. Correct? This is my target.
Yes, sir.
Okay. This is my target. So here I will just concentrate. Let's see, sum of n terms. Whether can I write this is equals to n upon 2 times A1 plus n minus 1 into D1. This complete is divided by n upon 2 times A2 plus n minus 1 times D2. This is equal to 3n plus 8 upon 7n plus 8. Simple simplification is there. This will get cancelled out. Okay. Now 2a1, 2a2 is there, and now we will approach how to approach this question. Partly we will think in the forward direction, and partly we will think in the reverse direction. As reverse direction means as to where do we want to go, what is our direction. Here we can calculate the exact value of A1, D1, A2, D2 because it's so many variables are there and we just have one equation. So exact values are not possible to calculate. However, exact values are not needed also. What is needed? A1 and 11 D1, A2 and 11 D2. If I observe my target, now here it is A1 plus something, A2 plus some combination of D2. And on the left hand side, I have twice A1 plus some n minus 1 D1, twice A2 plus something of D2. So let me just, let's see, I will in the reverse direction, I will just approach that. Sir, if at all, by chance, if I'm able to calculate twice A1 plus 22 D1, means the numerator and denominator both I'm multiplying by 2. My target is A1 plus 11 D1 or A2 upon A2 plus 11 D2. It is same as my target is twice A1 plus 22 D1 upon twice A2 plus 22 D2. This is my target. Whatever this value will become, that actually is my answer. So concentrating on the target and comparing this target where I want to go, that target with the what information I have in my hand. So 2a1 plus this n minus 1 d1, and here it is a 2a1 plus 22 d1. So sir, now can I make this n minus 1 equal to 22? If at all I am able to make this n minus 1 equal to 22, then the numerator will match my target destination where I want to. Or what about the denominator? Whether my denominator will match my target destination if I make n equal to 23. Let's check. If I take n equal to 23, twice a2 plus 22 d2. Yes, luckily for me, the denominator also is matching the destination with the target. So I will write here substitute n equal to 23. Why I am substituting n equal to 23? That logic I have told you, the means the thought process. Why are we substituting n equal to 23? So on substituting n equal to 23, we get twice a1 plus 22 d1 upon twice a2 plus 22 d2 will be equal to, we have substituted 23. So this become 23 minus 1, 22. And here it will be 3 into 23 plus 8 divided by 7 into 23 plus 8. Do the calculations. Numerator is 69. 69 plus 8. This is 77. And denominators 23 sevens. How much it comes out to be? 161. 161 plus 8 is 170. 169. 77 upon 169 is the answer. And if you reduce it, we made some mistake. Okay, yes. 3 and 77.169 will be the answer. Okay. Yes or no? So this is the answer, 77 upon 169. Got it, Pujita?
Yes, sir.
Okay. Similar question I will give you. Now this you solve on your own. The sum of two terms are in the.
Let us copy the answer. Will you let us copy the answer? First one, sir.
Okay. The sum of first n terms. The
Sir,
sum of,
I have took the screenshot so you can scroll down because there is no power in my house, sir, so I cannot write. I'll just take the screenshot.
okay, take the screenshot.
Took, sir.
Okay. The sum of first n terms of 2AP are in the ratio 7n plus 1 upon 4n plus 27. Find ratio of the 11th term.
Sir,
Yes, tell me, Pujita.
previous sum I got one doubt. From where we did get 22, sir?
did that calculation in the reverse order. This was my target. A1 plus 71 A upon A2 plus 72. This was my target. This I wanted to calculate. Okay, that was asked of me. Find the ratio of the 12th term. 12th term of first AP is what? A1 plus 71. Second AP, the 12th term is what? A2 plus 72. Yes or no?
Yes, sir. Yes, sir. Yes, sir.
So if this is asked of me to calculate this ratio, is actually what if I multiply the numerator and denominator both by 2? Did I do some mistake? So it is twice A1 plus 22D1 and denominator is twice A2 plus 22D2. This is what is asked of me. It's actually they are one and the same thing, no? Equality.
Yes, sir. Yes.
So this is asked of me. Means when he's asking me find the ratio of the 12th terms, what actually he's asking me is twice A1 plus 22D1 upon twice A2 plus 22D2.
Yes, sir. I got.
Because I want this ratio. Come on, it should not take so much time. Okay, let's see. I'm explaining this part now. Afrin, did you get? See what is given of me is n upon
No,
2
sir. Actually, I am not.
twice A1 plus
176 by 101.
no wrong, Pujita. Twice A1 plus n minus 1 times D1. This is my sum of n terms of the first AP, and the second AP will be, sir, n upon 2 times twice A2 plus n minus 1 into D2. This is given to be equal to 7n plus 1
Sir,
upon
176 by 127.
no, still wrong. 7n plus 1 upon 4n plus 27. This gets cancelled out. Okay, so this is the information that is known to me. And what is my target? My target is what he has asked of me is the sum of the ratio of the 11th term. Ratio of the 11th term is something like A1 plus 10 times D1 upon A2 plus 10 times D2. This is asked. Yes or no? So if he has asked this value, A1 upon A1 plus 10 times D1 upon A2 plus 10 times D2, this is same as twice A1 plus 20 D1 upon twice A2 plus 20 D2. This is my target, and whether comparing it with what information we have at hand, twice A1 plus n minus 1 D1 upon twice A2 plus n minus 1 D2. This is the information that we have at hand, that is 7n plus 1 upon 4n plus 27. So what we observe is, sir, if at all by chance, if anyhow we can make this n minus 1 equal to 20, the bottom also n minus 1 should be 20. If at all I can make that 20, then my work will be over. So we will put n is equals to 21. So we will substitute n is equals to 21. So that on the LHS it becomes twice a1 plus 21 minus 1, that is 20 times d1 divided by twice a2 plus 20 times d2. This will be equal to 7 into 21 plus 1 upon 4 into 21 plus 27. Okay, so this is equal to 147. This is 127. 147 plus 1, this is 148, and denominator is 21 4 is 84. 84 plus this is 111. Both are divisible by 37 4s are, and this is 37. This is the answer. Got it, Pujita? Afrin?
Yes, sir. Yes, sir. I got, sir.
Okay, where
Yes, sir.
the mistake where you were doing, did you understand what mistake you were doing?
Yes, sir. I got, sir.
Okay.
Sir, one more sum, sir.
So we do now properties of AP now. Afrin, your voice is breaking. I think you're asking some doubt. I think so. I cannot hear your voice.
So can you scroll down? So
Screenshot. Okay, take
yes,
it.
sir.
Yeah, this is the complete solution. Yeah, take the screenshot quickly.
Done, sir. Done, sir.
Now, properties of an arithmetic progression. First property, if each term of an AP is increased or decreased, is increased, or maybe let's say decreased, or maybe let's say multiplied, divide terms, multiplied, divided by same number, then resulting sequence is also an AP. This property is very useful. For example, let's say consider the original sequence. Original sequence, let's say original sequence will consider only generalized result only will consider A, then D steps ahead, then again A plus 2D, A plus 3D, and so on and so on and so on. Suppose I add a particular constant K to all of them, addition K. Okay, addition of a constant K. So what the term becomes, the first term becomes A plus K, and the second term what becomes A plus D plus K. The third term becomes A plus 2D plus K. What is the fourth term? A plus 3D plus K. Can you see that the result, that common difference is still D only? A plus D plus K and A plus K. Whether the common difference is D?
Yes, sir.
A plus D plus K and A plus 2D plus K. Whether the common difference is D? Still the common difference is D. Yes or no? Geometrically, what it will mean means on the number line, the picturization. The picturization of this thing will mean that, sir, on the number line, initially the points were something like this: A plus D, A plus 2D, A plus 3D. They were equally spaced points. And now plus K plus K plus K. If a positive number is added, then all the numbers, all these points which are there, this is A plus D, This is a plus 2d, this is a plus 3d. If k is positive, a plus k, a plus d plus k. So if you are adding a positive number, all of these points are shifting to the right side by same equal distances. So ultimately the new distance is again the same only, as previously. The previous intermediate distances was d. Now also the intermediate distance will be d only, because all of them are shifting to the right side with the same unit. If k is negative, they will shift to the left side, all of them. For subtraction also the result will be same. No means nothing new. A minus k, a plus d minus k, a plus 2d minus k, a plus 3d minus k. Clear up to this point?
Yes, sir.
Okay. Now this was for addition. For multiplication, well, let's say multiply by k. The original sequence is a plus d, a plus 2d. The new sequence will be k times a. This will be, sir, k into a plus d. K into a plus d will be what? K times a plus k times d. Yes or no? A plus 2d, this is complete. A plus 2d, this complete is multiplied by a. So what it will become? So k times a plus k times 2d. So 2 into kd, it will become a plus 3d. A plus 3d when it multiplied by a. So k times a plus 3kd. Yes or no? And so on. What is the difference now? Consecutive difference. So the consecutive difference is the difference in consecutive terms. Ka and kd. So here the common difference is kd. Ka plus kd and ka plus 2kd. So here again the difference is kd. Here ka plus 2kd, ka plus 3kd. Here the difference is kd. Yes or no? Still the difference is same. So this is an arithmetic progression only. Okay. The only thing that has changed slightly is the common difference. In the original arithmetic progression, whatever that difference was, the difference was of d. Now the new common difference is of k times d in multiplication, and division it will be d upon k. In addition and subtraction, the common difference remained the same. It did not change. The arithmetic progression changed, but the common difference remained same. In multiplication and division, the common difference is also changing. It is multiplying by factor k, dividing by factor k. But still the new sequence is again an. Can you see this result, everyone? Afrin and Pujita.
Yes,
Pujita,
sir.
take the screenshot quickly. Afrin.
Yes, 1 minute.
Done?
Yes.
Okay. This result is true for mainly non-zero numbers, but if you, let's say, add a zero, if you're adding zero or subtracting zero, means you're not doing anything. You're getting the same sequence only. And if you're multiplying by division by zero, so not defined. Okay. And multiplying by zero, so if you multiply a sequence by zero, so all the terms will become zero. So okay, that is a trivial result, but still it will be an AP only. 0, 0, 0, 0, 0, 0. All the terms are same. This is still an AP. So this is a generalized result. We need not bother. Now second is, let's say, the sum of two terms. This property I've given you earlier also. The sum of two terms equidistant from the first term and the last term. Equidistant from the first term and the last term. Is same, is constant, and is equal to sum of first and last term. This property I told you while when we derived the formula of Sn also. Means Sn, how we derived it? So A1, A2, A3, and here is, let's say, An. The previous term will be A n minus 1. Even the prior term will be An minus 2, and so on. If I do the addition pairwise, A1 and A1 plus An, if I do, so A1 plus An. Next term, if I do A2, so means what, sir? I have moved D units ahead of A1. So A1 is D units greater than A1. So, but sir, An minus 1. An minus 1 is D units less than An. So instead of An, if I write, sir, An minus 1, this addition, this will be equal. Are you getting this? In addition, we did this part. Because why? A2 is what? The rough work we did, sir. A2 is actually nothing but A1 plus D. This was A1 addition D, and this An minus 1 is what, sir? An subtraction D. So this gets cancelled out. So it remains as A1 plus An only. A3, if I go on, A3 is what actually, sir? A3 is A1 addition 2D. So An, if I do subtraction 2D means we have come 2 steps before An. Subtraction 2D, if I go, so 2 steps before if I come. So this gets cancelled out, and the final result is same as A1 plus An. Okay. So 2 terms, first term and the last term. The first term and the last term which are there, and the sum of 2 terms equidistant from them. Means if you do 2 steps ahead, that is, you reach at the third term, 2 steps backwards from the last term, and you add them. The result will be their pairwise addition. All of them, their result is same. So generalized result, if I want to write of this form, this will be equal to, sir, A1 plus K. A1 plus K means what? 1 plus kth term. Means you have went K steps ahead of this. So from in the last term An, you will have to come K steps behind. K steps behind means N minus K it will be. So this will be the result that I will have. A1 plus An is equals to A2 plus An minus 1 equal to A3 plus An minus 2, A1 plus K, An minus K. Got it? This N minus K is complete subscript. A1 plus K is complete subscript. Afrin, Pujita, both of you clear?
Yes, sir.
Okay.
Yes, sir.
So similar result to this one. A1, A2, A3, and 4 is similar. Fourth property I can write. Fourth property, An, any term of an AP is equal to sum or half of sum of terms which are
Sir, one scroll down.
equidistant from it. Let's take the screenshot.
So
Done?
the previous question you have written as second, and the question which you are writing now you have written as fourth.
No, sorry.
Sir, yes, sir. That's what I was saying.
Any term of
Yes,
AP is equal to half of sum of terms which are equidistant from it. This property is actually a corollary of the second property only. Means what he is telling you that A1, A2, A3, so on. Let's say there is AN minus 2, AN minus 1, AN. You take any term of your choice. Okay, A3 now. So let's say if I take A3, A3. If you add A3 can be written as what, sir? If I can write A3, I can write here A3 plus D, A3 plus A3 upon 2. Yes or no? A3 plus A3 upon 2. Now, if I add in this A3, if I go D units ahead, this is separate. And if I go D units backwards, this is separate. Is it correct? So on A3, when I'm going D units ahead, means where I have landed, so the next term. From A3, when I'm going D units backwards, where I have landed, so the previous term. So A4 and A2 addition, half of that. Got it? Same result, sir. A3 I could have written as A3 addition A3 upon 2. Instead of adding D, sir, if I would have added, let's say, A3 plus 2 times D and subtracted 2 times D, whether the result is same, whether up till this point I'm doing correct. So A3 plus 2D separate. What is this? So the term 2 units next means the term 2 succeeding to the term which is succeeding A3, but 2 units apart. 2 units succession term is A5, and 2 units prior term is A1 upon 2. Okay, got it? So this is the result. That is, if you go 2 units backwards, 2 units previous and 2 units next, half of that will be the term that you started from. Is this result clear what I'm trying to say? So any term is half of sum of terms which are equidistant. So A3, I gave you an illustration with respect to A3. So this will be next term is A4 and previous term. A4 plus A2, half of that. A5 plus A1, half of that. So AN, generalized result is AN. AN will be what, sir? Nth term. You go for the term wise succession term is K units ahead you go. K units means term wise. K units ahead of that next term, and you come K units previous to that. So if I put, let's say, K equal to 1, if I put K equal to 1, you are taking immediate next term and immediate previous term. If I put K equal to 2, you are taking the alternate succession term and the alternate prior term, that way. So AN equal to AN plus K, AN minus K, terms equidistant from AN, and half of that. Is this result clear?
Yes, sir.
Yes, sir.
Similar result, I can also say that if you can see this result for yourself, AN. Try to think whether this result you can get for yourself. Previous terms and next terms are, let's say, A N plus K, A N minus K. In K addition means the addition of these two terms. Similarly, from AN only I'm starting. Everywhere I'm starting from AN only. So N plus K and N minus K. N plus, let's say, M and a N minus M. They are addition. This way upon Now here I will have to take 4. That is the only thing. Means what? You have taken these two. Means a n plus k and n minus k. These two are brothers. These two are brothers. They form a pair. The equidistant term from nth term. N plus m, n minus m. These two terms are brothers. Equidistant terms from a n. So from a n, let's say next term and previous term you added them. That will be 2 times a n. Even the further term, even the backward term, their addition will be 2 times a n. So these two together they give me 2 times a n. These two together they give me 2 times a n, that is 4 a n. And when I divide it by 4, I get a n. Can you see this result?
Yes, sir.
Okay. Similarly, you can do for 6 terms also, taking 8 terms also. Just take equidistant.